While today this volcano looks calm and peaceful, it wasn't always that way. On the afternoon of May 22nd, 1915, Lassen Peak, seen here, erupted in a massive explosion, spewing volcanic ash and gas more than 30,000 feet, or over 9,000 meters, into the sky. For days and months, molten rock poured out, and ash rained down as far as 200 miles away, or 320 kilometers. In Lassen Volcanic National Park, located in Northern California, the evidence of the eruption is vividly clear. Deep volcanic ash blankets the landscape. Huge boulders ejected from the blast dot the countryside. And hardened lava flows mark the trails of once flowing, sizzling molten rock. Today, hot springs provide evidence that volcanic activity does not loom far below the surface, leading scientists to believe this area may erupt again someday. During the next few minutes, we're going to take a look at the rocks produced by magma and lava called igneous rocks, as well as the characteristics of metamorphic rocks created by heat and pressure. When this fuse is ignited, it has the potential to create an explosion. The words ignite and igneous are derived from the Latin word ignis, meaning fire. In the creation of igneous rocks, heat plays a very important role. Igneous rocks are formed from molten or liquid rock crystallizing inside the earth or on the surface. Igneous rocks are the most common rocks on the surface of the globe. Igneous rocks are used for a wide variety of things. Walls and buildings are made of igneous rocks. Rock climbers, seen here, scale towering cliffs of igneous rock. And igneous rocks are even used in barbecue grills to distribute heat. Let's now take a look at the origins of igneous rocks. As we just mentioned, igneous rocks form as a result of cooled molten rock. You decide. What is the source of molten rock? Molten rock originates deep within the earth and is called magma. While the surface of the earth is quite solid, 60 to 200 kilometers beneath the surface, rocks can be quite soft and even exist as liquid. Temperatures reaching 1400 degrees Celsius, created by great pressure from overlying rocks, turn hard rock into liquid magma. Magma is less dense than the surrounding surface rock and can be forced upward. In some cases, it may reach the surface flowing out of volcanoes. Molten rock on the surface of the earth is called lava. Below the surface, magma may come in contact with water, which becomes superheated. This superheated water has the ability to rise to the surface, forming geysers and hot springs. This line of light-colored rock was originally formed deep underground from magma, which later hardened. Magma oozed itself between rock layers and then cooled to form igneous rock. Notice the light-colored lines in this cliff? These were formed when magma intruded into this rock when it was buried beneath the surface. Magma that hardens inside the earth forms a type of rock called intrusive rock. When magma cools, crystals called mineral grains form. Generally, molten rock that cools inside the earth cools slower than on the surface. Slow cooling allows larger crystals to form. This igneous rock, formed inside the Earth, called pegmatite, possesses large crystals. Extrusive rock forms when molten rock or lava on the Earth's surface cools. Because the air on the Earth's surface is cooler, igneous rocks tend to cool and solidify quickly. This quick hardening does not allow time for large crystals to form. Therefore, extrusive igneous rocks, such as this rhyolite, tend to have smaller crystals. This piece of obsidian cooled so quickly that there are no visible crystals, making it appear almost glass-like. In some extrusive rocks, such as pumice and scoria, air and other gases become trapped inside them as they cool, creating holes and air pockets. This enables some rocks, such as pumice, to float. You decide. From what substance is this red candle formed? This candle was formed from red liquid wax that cooled. Similarly, igneous rocks are created from different types of magma or lava. From what type of lava do you think scoria is formed? Scoria is formed from basaltic magma, a type of dark magma. The major minerals of igneous rock play an important role in their appearance. Light-colored igneous rocks, such as this rhyolite, contain a great deal of silica, a glass-like mineral. Whereas dark mineral rocks, such as basalt, are formed from magma which has a high concentration of magnesium and iron. The environment in which igneous rocks are formed also has an impact on them. For instance, you can often tell if a rock was formed inside the Earth or outside the Earth's surface by the rock's texture. Fine-grained rocks, such as this andesite, are believed to have formed on or close to the surface of the Earth. You decide. This igneous rock, called gabbro, is large-grained. Where do you think it formed? Gabbro is formed from the cooling of magma deep within the Earth. As you can see, the characteristics of igneous rocks can tell us a lot about the environment in which they were created. For example, this dark rock, called basalt, has small crystals and therefore cooled quickly. Basalt is the most common rock on Earth, covering the majority of the ocean floor. Yosemite National Park, located in the Sierra Nevada mountains, is one of the world's most vivid examples of granite. Granite is an igneous rock which is mined from quarries such as this, so that it may be used in making road curbing and buildings. Granite is commonly made of a number of minerals, including feldspar, quartz, mica, and hornblende. The granite seen here on Half Dome in Yosemite was formed deep underground where the magma hardened. Over many years, the granite was folded, uplifted, and eventually exposed as a result of erosion and glacial movement. Today, we see sheer walls of granite with spectacular 1,000-foot waterfalls. You decide. What will happen to these small beads of clay if you squeeze and heat them in your hand? As you can see, they all turn into a single piece of clay. A similar process takes place deep underground. Existing rocks buried deep within the earth can be exposed to tremendous heat and pressure. This heat and pressure, along with chemical reactions, can change rocks dramatically. Metamorphism is the process of changing one kind of rock into another kind of rock via heat, pressure, or chemical reactions. To get an idea of how intense the heat and pressure created within the earth is, try stacking books on top of your hand. As more books are added, you feel the pressure increasing. Imagine the pressure created by layers of rock thousands of feet thick. This is a marble quarry. Marble is a beautiful metamorphic rock used in making buildings, walls, steps, and is even used in toothpaste. But this marble did not always exist as a metamorphic rock. The marble seen here in New England was formed from sedimentary rock called limestone. The limestone was formed underwater when shallow seas covered the landscape, depositing shells, crustaceans, and other ocean life, which eventually solidified into limestone. Under heat and pressure, the limestone compressed to form much denser and smoother marble. So, when you walk across a marble floor, you're actually stepping on the altered remains of once living sea creatures. You probably do not like to eat raw eggs, so you cook them. Heat from the frying pan causes the egg to change chemically. Its color and texture changes to one you're used to eating. Notice that the portion of the egg closest to the heat becomes white. During a process called contact metamorphism, rocks go through a similar process. Contact metamorphism occurs when magma inside the earth goes into or intrudes existing rock. The rock that is in contact with the magma becomes superheated and new types of rock are formed. Regional metamorphism can affect huge areas of rocks. Regional metamorphism tends to occur at the boundaries of plates, where large areas of rock are deeply buried. Pressure and heat created by the thick layers, as well as possible contact with magma, gives rise to the creation of large areas of metamorphic rocks. This rock, called schist, was most likely created as the result of regional metamorphism. You decide. From what metamorphic rock is this roof made? If you said slate, you're right. Slate has been used for centuries as roofing on buildings. Slate is a metamorphic rock that is derived from a sedimentary rock called shale. Shale is made of fine-grained sediments. Slate is easily split into flat leaves, which make it ideal for laying on roofs. This is because its grains are arranged in parallel bands. This is referred to as foliation. Slate becomes foliated when the grains in shale flatten under heat and pressure. The grains are typically compressed so that water cannot pass through them. This schist is another common metamorphic rock and is also foliated. Metamorphic rocks tend to be either foliated or non-foliated. Watch what happens when this piece of marble is broken. It does not break along flat, even bands like slate. In non-foliated rocks, such as marble, banding does not occur, causing the rock to break in uneven, random fragments. During the past few minutes, we've taken a look at some of the characteristics of igneous rocks. We've taken a look at how magma forms rocks, such as granite, deep within the earth, and how lava forms rocks, such as basalt and pumice on the surface of the earth. We explored how the characteristics of different types of igneous rocks can tell us a great deal about the environment in which they were formed. We also studied metamorphic rocks, rocks changed by heat and pressure from other pre-existing rocks. We investigated how metamorphic rocks are created either via contact metamorphism or via regional metamorphism in large areas. Finally, we took a look at differences between foliated and non-foliated metamorphic rocks. So the next time you walk across a marble floor, use a barbecue, or look at a slate roof, think about some of the characteristics of metamorphic and igneous rocks. You just might look at your world a little differently. Fill in the correct word when you hear this tone. Good luck, and let's begin. Number 1. Rocks are formed from molten rock. Number 2. Molten rock on the surface of the earth is called Number 3. Rock is formed inside the earth. Number 4. Igneous rocks with large crystals cool. Number 5. Rocks are created via heat and pressure from existing rocks. Number 6. Metamorphic rocks that break along flat, even bands are Number 7. Is an igneous rock common on the ocean floor? Number 8. Igneous rocks on the Earth's surface cool. Number 9. Under heat and pressure, limestone may form. And number 10. Metamorphism occurs over large areas.